Good evening, everyone. We are from Group 6, and now we are going to present you Chapter 5.2, which is about building sustainable MIS infrastructures. My name is Robertus.
My name is Alaya.
My name is Danya.
My name is Natasha.
My name is Joe.
My name is Kamal.
So, mist and the environment. The general trend in mist is towards smaller, faster, and cheaper devices. Moore's law refers to the computer chip performance per dollar doubling every 18 months. Moore's law is great for many companies because they can acquire large amounts of MIS equipment for cheaper and cheaper cost. As e-business continue to grow, companies equip their employee with multiple forms of electronic devices ranging from laptops to cell phones to iPads. This is great for supporting a connected corporation. But significant unintended side effects include our dependence on fossil fuels and increased need for safe ecological practice known as sustainable mist. Sustainable mist describes the production, management, use, and disposal of technology in a way that minimizes damage to the environment. Sustainable MIS is a critical part of a corporate social responsibility. Clean computing, a subset of sustainable MIS, refers to the environmentally responsible use, manufacture, and disposal of technology, products, and computer equipment. Although sustainable MIS refers to the environmental impact of computing as a whole, clean computing is specifically focused on the production of environmental waste. A green personal computer, green PC, is built using environment-friendly materials and designed to save energy. Building sustainable MIS infrastructures is a core initiative and critical success factor for socially responsible corporations. Next, please. And there are three primary side effects of business expanded use of technology. The first one is increased electronic waste. It refers to discarded, obsolete, or broken electronic devices. For example, CDs, DVDs, cell phones, etc. The second one is increased energy consumption, the amount of energy consumed by business processes and systems. And the last one is increased carbon emissions. Includes the carbon dioxide and carbon monoxide produced by business process and systems.
Grid computing will be discussed next. So grid computing refers to a collection of computers, often geographically dispersed, that are coordinated to solve a problem. So with grid computing, a problem is split into pieces and distributed to many machines for faster processing than a system can handle on its own. Computers typically have 75% available processing power uh, for grid computing because in a usual use of computers, only 25% is used. So there are several advantages of using grid computing, which includes making use of available processing power, which was explained before. It uses MIS resources. It is more cost efficient because it includes the contribution of hundreds and thousands of computers to solve a single problem. And also, it is able to tackle problems that cannot be solved only by a single computer. Next slide. So grid computing has been used by virtual organizations such as DreamWorks. So DreamWorks is an animation company which uses grid computing for animated movies, which we all know, such as Shrek and Madagascar. So for example, over 4,000 computers were used to complete the animation movie Shrek. So in DreamWorks, there are three major steps of using grid computing. Previous slide, please. Okay. So the first step is the artist uses digital 3D characters and scenes of graphic workstations. These can handle designs, but they are not able to handle large data to flesh out figures. That's why more than one computer is used. The second step is that grid software deals out of animations in bite-sized pieces to a cluster of server computers, DreamWorks data centers. These add colors, textures, and lighting to the animation. The third step is if more computing is needed, work is framed out to more computers. So when all the pieces are complete, they are then assembled for the final editing. Aside from that, grid computing is also used for energy issues using smart grids. So a smart grid delivers electricity power using a two-way digital technology. It is meant to solve the problem of the outdated electrical grid by making it more efficient and reliable to control the transmission of power. So in other words, it helps solve um, problems regarding to excessive energy usage. So Smart Grid provides users with real-time usage monitoring, allowing them to pick off times for less urgent or less critical electrical processes. For instance, the company Excel Energy has helped its users lower their energy usage by 45% using grid computing.
So now we are going to discuss about virtualized computing. Most computers and servers typically run only one operating system, such as Windows or Mac OS. Through the use of virtualization, computers can run multiple operating systems along with multiple software applications all at the same time. Virtualization creates multiple virtual machines on a single computing device. A good analogy is a computer printer. In the past, you had to purchase a fax machine, copy machine, answering machine, computer printer separately. This was expensive, required enough energy to run 4 machines, and created additional amounts of e-waste. Today, you can buy a virtualized computer printer that functions as a fax machine, answering machine, and copy machines all in one physical machine, thereby reducing costs, power requirements, and e-waste. Next slide, please. So virtualization is essentially a form of consolidation that can benefit sustainable MIS infrastructures in a variety of ways. For example, by increasing availability of applications that can give a higher level of performance depending on the hardware used. The second one is by increasing energy efficiency by requiring less hardware to run multiple systems or applications. And the third one is by increasing hardware usability by running multiple operating systems on a single computer. Next, please. So originally, computers were designed to run one single application on a single operating system. This left most computers vastly underutilized. So virtualization allows multiple virtual computers to exist on a single machine, which allows it to share its resource such as memory and hard disk space to run different applications and even different operating systems. For example, Mac computers can run both Apple operating system and Windows PC operating system. Next, please. So this figure is an example where Mac computers can run both Apple operating system and the Windows PC operating system with the use of virtualization software. So unfortunately, virtualization, like at least for this moment, is still not available for PC to run Mac software. Next, please. So there are three basic categories of virtualization. The first one is storage virtualization, where it combines multiple network storage devices, so they appear to be a single storage device. And the second one is network virtualization, where it combines networks by splitting the available bandwidth into independent channels that can be assigned in real time to a specific device. And the last category is server virtualization, where it combines physical resources such as servers, processors, and operating systems from the applications. So the server virtualization is the most common form. Typically, when you hear the term virtualization, you can assume it is server virtualization. Next, please. Okay, so virtualization is one of the easiest and quickest ways to achieve a sustainable MIS infrastructure because it reduces power consumption and requires less equipment that needs to be manufactured, maintained, and later dispose of safely. So system virtualization is the ability to present resource of a single computer as if it is a collection of separate computers, each with its own virtual CPUs, network interface, storage, and operating system. A virtual machine technology was first implemented mainframes in the 1960s to allow the expansive systems to be partitioned into separate domains and used more efficiently by more users and applications. Next, please. So virtual machines appear both to the user within the system and the world outside as separate computers. each with its own network identity, user authorization, and authentication capabilities, operating system version and configuration, applications, and data. So a data center is a facility used to house management information systems and associated components such as telecommunications and storage systems. Data centers, sometimes referred as server farms, consume power and require cooling and floor space while working to support business growth without disrupting normal business operations and the quality of service. So the amount of data a data center stores has grown exponentially over the years as our reliance on information increased. Next slide, please.
Okay, so now we're going to discuss about cloud computing. So by definition, cloud computing stores, manages, and processes data and applications over the internet rather than on a personal computing or server. Cloud computing makes it easier to gain access to the computing power that once preserved for large corporations. So to the users, cloud application appears as their personal application, device, or document. It's like storing all of your software and documents in the cloud. And all you need is as a device to access the cloud. No more hard drive, software, or processing power is required. So users are not physically bound to the network. They can access the programs whenever they need to. Even if the machine crashes or data is lost, it can still be accessed as long as they have connection to the internet. So this diagram represents cloud computing. So basically, you only need mobile devices such as tablets, phones, or computers, and by the access of internet, you can access the cloud to Windows Live, Amazon E2C, Gmail, Facebook, and Mozi. So this is the overview of cloud providers. The first one is Microsoft. The examples are Office 365, OverDrive, OneNote, and Exchange. OneDrive and Office 365 offer ways to collaborate and share data, photos, email, and documents. So the next example is Amazon, Cloud Drive, Cloud Player, Amazon Prime. Amazon Kindle Fire is sold at a loss to push various types of media through Amazon Prime and Cloud Player, where users can stream videos and music. So from Apple, they have iCloud, iWork, iBooks, and iTunes. iCloud brings together iPhones, iPads, and Mac to synchronize data across Apple devices. iWork helps users to collaborate. The last example is from Google, which have Google Apps, Google Drive, Gmail, and Google Calendar. Google offers a number of cloud services, including Google Apps, Gmail, and Google Drive to store data.
Now we're moving on to the cloud computing advantages. Some of the advantages of cloud computing refers to accessibility, availability, scalability, backup, capacity on demand, portability, reliability, flexibility, and cost saving. The cloud offers a company higher availability, uh, is quickly becoming a viable option for companies of all sizes. Here, there are many keynotes I need to remember to refer cloud computing advantages. The first one is Cloud Fabric. The Cloud Fabric is the software that makes possible the benefits of cloud computing, such as multi-tenancy. Multi-tenancy in the cloud means that a single instance of system serves multiple customers. In the cloud, each customer is called tenant, and the multiple tenants can access the same system. But this advantage of multi-tenancy can cause noisy neighbor, which means refers to total multi-tenancy continent that monopolize bandwidth, servers, CPUs, and other resources that cause network performance issues. Next slide. Now, moving on to the characteristic of cloud computing. The first characteristic is on-demand self-service. Here, users can increase storage and processing power as needed. The second one is broader network access. It means that all devices can access the data and applications. The third one is multi-tenancy. Here, customers share pooled computing resources. Then it comes to rapid elasticity, means that storage, network, bandwidth, and computing capacity can be increased or decreased immediately, allowing for optimal scalability. And the last one is measured service. Moving on. This is some of the environments of cloud computing. The first one is public cloud. Public cloud promotes massive global and industry-wide application offered to the general public. Some other characteristic of private public cloud is it has multi-tenancy, it's off-premises, and it is used by several organizations. For example, it contains Amazon EC2 and Windows Azure. The second environment is private cloud. Private cloud serves only one customer or organization and can be located on the customer's premises or off the customer premises. The, characteris- the characteristic of private cloud is single tenancy, on-premise, and is only used by one organization or one individual. And the example is bank, government, and corporation. The third environment is community cloud. Community cloud serves a specific community with common business models, security requirements, and compliance consideration. One of the characteristics is multi-tenancies, similar to public cloud. It has off-premises and it can be used by several organizations. Examples of community cloud is private hospital, all Colorado state government organizations. And the last environment is hybrid cloud. Hybrid cloud contains two or more public, private, or community clouds, but each cloud remains separate and is only linked by technology that enables data and application portability. For example, private cloud of a company and a public cloud for customers, suppliers, and also partners.
Okay, now I'm going to talk about utility computing. Utility computing offers a pay-per-use revenue model similar to a meter service such as gas electricity. Cloud computing service providers use utility computing cloud infrastructures, which are for infrastructure as a service that is offers computer hardware and networking equipment on a pay-per-use basis. For example, it's like Amazon EC2, Rackspace, and Google Cloud Storage. The second one is software as a service, which offers application on a pay-per-use basis, for example, Salesforce.com and Google Apps. And the last one is platform as a service, which offers hardware, networking, and application on a pay-per-use basis. For example, is Google Application Engine and Amazon Elastic. Next slide, please. Okay, now I'm going to talk more further about infrastructure as a service or IaaS. IaaS delivers hardware networking capabilities, including the use of server, networking, and storage over the cloud using a pay-per-use revenue model. With using IaaS, the customer runs hardware and provides its own custom application and or programs. The customers save money because they not have to spend a large amount of capital purchasing servers, which is great for business advantage. The service typically paid for an usage basis, much like a basic utility service, such as electricity or gas. IaaS also offers a cost-effective solution for companies that need their computing resources to grow and shrink as business demand changes. This is known as dynamic scaling. Dynamic scaling means the MIS infrastructure can be automatically scaled up or down based on requirements. Disaster Recovery as a Service offers a backup service that uses cloud resources to protect application and data from disruption caused by disaster. DRAAS is typically part of a disaster recovery plan or business continuity plan. IaaS is perfect for companies with research incentive projects that need to process large amount of information at irregular intervals, such as those scientific or medical fields. Cloud computing service offers these companies considerable cost saving because they can perform testing and analysis at levels that are not possible without access to additional and very costly computing infrastructure. Next slide, please. Next, we're going to talk about software as a service or SaaS. SaaS delivers application over the cloud using a pay-per-use revenue model. Before its introduction, companies often spend huge amount of money implementing and customizing specialized application to satisfy their business requirements. Usability was one of the biggest drivers for creating interest and success for cloud computing service providers. SaaS has several advantages, which are tremendous cost savings. The software is priced on a pay-per-use basis with no upfront costs, so companies get the immediate benefit of reducing capital expenditures. They also get added benefit of scalability and flexibility to test new software on rental basis. SaaS can provide access to a large-scale, secure infrastructure along with any need support, which is especially valuable for a startup or a small company with a few financial resources. SaaS extension include data as a service or DaaS that facilitates the accessibility of business critical data in a timely, secure, and affordable manner. DaaS depends on the principle that specified useful data can be supplied to users on demand, irrespective of any organizational or geographical separation between consumers and providers. The second one is security as a service or SaaS that involves applications such as antivirus software delivered over the internet with constant virus definition updates that are not reliant on user compliance. SaaS, sometimes referred to as cloud security, which provides top security expertise that is traditionally better than can be found in organization. That includes Cisco, McAfee, and Symantec. The last one is Unified Communication as a Service or UCaaS, which offers enterprise communication collaboration service over the internet such as instant messaging system, online meetings, and video conferencing. Business using UCaaS avoid large payouts and expenses associated with developing unified communication solution on their own. Another advantage of using UCaaS is that it provides core business tasks with a high level of availability, flexibility, and scalability. Next slide, please. The last thing I'm going to talk about is Platform as a Service or PaaS. PaaS supports the development of entire systems, including hardware, networking, and application, using a pay-per-use revenue model. PaaS is a perfect solution for a business because it passes on the service provider the headache and challenges of buying, managing, and maintaining web development software. With PaaS, the development, deployment, management, and maintenance is based entirely in the cloud and performed by the PaaS provider, allowing the company to focus resources on its core initiatives. Every aspect of development, including the software needed to create it and the hardware to run it, lives in the cloud. PaaS helps companies minimize operational costs and increase productivity by providing all the following with upfront investment, which are the first one is increased security, second one is access to information anywhere and anytime, third one is centralized information management, fourth is easy collaboration with partners, suppliers, and customers, and the last one is increased speed to market with significantly less cost. Combining infrastructure as a service, platform as a service, and data as a service, there is big data as a service. PDAAS offers a cloud-based big data service to help organizations analyze massive amounts of data to solve business dilemmas. PDAAS is somewhat nebulous terms often used to describe a wide variety of outsourcing of various big data functions to the cloud. This can range from the supply of data to the supply of analytical tools with which to interrogate the data to carrying out the actual analysis and providing reports. That's all from us. Thank you.